Okay, welcome to this session. So in this session we are going to discuss on the methods what we are going to use for geometric transformation, a different method. All these sessions what we have discussed for geometric transformation, we are using the matrix method or the homogeneous matrix equations, so which is going to give us the geometric transformation. But this is a different way of dealing with geometric transformation, so it won't be as feasible as what we discussed with the matrix way of geometric transformation, but it's going to give a simple way. And for simple transformation we can make use of one more method called as raster method. And there are few OpenGL raster functions available in OpenGL program, so which is going to give you how exactly you need to implement the geometric transformation function with the available raster functions. Hence we will discuss few OpenGL raster functions which can be used for simple 2D transformations. So in this sense, so first understand what exactly the raster is going to do. So at the beginning of the classes we were discussing about the display systems or the display monitor or the raster scan display, if you remember, and even we have discussed few components with respect to raster scan display or the raster scan geometric on the graphic system, where we usually talk about the pixels and how the pixel information has been stored in a frame buffer and how this frame buffer pixel information is used as picture information to put on the display system. So with this that is, you are aware of what all this components is going to do with a raster system or a raster graphic system. That is, whatever you see on your display, it is the information or the data stored in the frame buffer. And if we are trying to deal with the pixels information which is stored in the frame buffer, we call this as raster method or we call this as raster system. Hence we say the raster method for geometric transformation is an alternate method which is going to perform certain 2D transformations and few 2D transformations. It cannot be used for complicated transformation, but for certain simple 2D transformations we can make use of this. I'm stressing out, it is for 2D transformation. This alternate method cannot be used for 3D transformation. Hence we are aware that the raster system stores the picture information what you see on the display system as the color patterns in the frame buffer, as the frame buffer contains set of pixel in the fashion in the form of array. Fine. Hence, so some simple object transformation can be carried out using the raster method, and it can be done rapidly as compared with the geometric transformation with respect to matrix or with respect to homogeneous coordinate system. Hence, so we can bring in this simple 2D transformation by either transferring or by manipulating the array of pixel values, specifically what part of frame buffer pixels I need to capture, I need to copy, and I need to alter, or I need to translate, or I need to transform. So all this we can do with few mathematical operation what we are going to put on the pixel information of a frame buffer. That is what we are going to talk about, this raster scan operations. Hence we say this as raster operations, and this raster operations is all about moving a block of pixel values. When I say frame buffer, it is the whole pixels, the whole pixel what your entire display is going to show you. The entire information will be stored in form of pixel in the frame buffer. So now in this frame buffer, the entire pixel array, you can create a block of pixels, and on that block of pixels you can perform any geometric transformation, and specifically a 2D geometric transformation. Hence, we are going to say what block of pixels we are going to subject it for the transformation. On that block of pixels, we are going to perform the raster operations. Hence, so when you do so, whatever the block of pixels we are going to work on to perform the geometric transformation, this is called as block transfer, or we are going to call this as bit block transfer, because every pixel is going to be bit of information. So now this bit will be a block. Now I am going to create a block of bits which is going to be pixel, and we are going to apply transformation or transfer. Hence we call this as bit blat. Or so this bit is the pixel information, hence we can even call this as pixel block transfer. Hence the raster operation which we are going to use an block of pixel for any kind of transformation, we are going to call in any of this term. Remember. And so now just look at this picture. Right now this is my entire display system, where this entire display system has been divided into pixels, that is smallest unit of your display system. Hence your frame buffer contains this entire display pixel information. So now there is an object which I need to apply some sort of transformation. So now to apply the transformation for this object, I need not work on every pixel of the frame buffer or the display. I am going to work on only the pixels area where the object is right now situated. And so now we are going to group these pixels, and we are going to create this as block of pixels now. And just observe, so this dashed rectangular space, what we call this as block, and whatever the pixels is going to be in this area, we call this as block of pixels. And observe, we have created block of pixel in such a way that the object will be the part of it. And so now for this block of pixel, if I apply any raster operation, if I copy this and if I paste somewhere over here, this is going to act as a translation. If I am going to copy this pixel and if I modify this pixel values using some mathematic operation, we are going to call about rotation. And for the same pixel object, if I reduce the size, that is if I am going to remove some pixel color to the background color and keep the remaining pixel color with the same color, we are going to call this as scaling operation. Hence, using some raster technique, now I am thinking about bringing in the transformation. That is, it can be translating, it can be rotating, or it can be scaling, and even we can use the same mechanism to apply the reflection transformation as well as the shear transformation. So now just look at this, whatever the block of pixels we have formed, so this is going to be the block of pixels, and each pixel has got its own information. It can be the color information, it can be the depth information. And so now I am going to store this as an array. This is going to be something like a 2-dimension array, or you can call this as a vector array. But all this in pixel information will be stored in form of an array information or array structure. And so now with this, now just look at how the translation is going to happen. So now this is the block of pixels which I need to apply transformation, and right now specifically the translation. And so now I am just going to copy this pixel. and I'm going to copy or shift entire this pixel information to a new position. Now this is going to be translation. Copy this entire pixel information, replicate or paste those pixel information on the destination point where you want to translate the object. Now this pixel value should be changed to the color which is going to be with the background color. Assuming there is no any other object behind this object, assuming there is no any overlap of other object, hence we are going to put, or we are going to convert complete pixel block information color to the exact background color what it's going to have. It is something like I am going to copy the object and I am going to erase the object in the original position. This is the mechanism or technique what I am using with the raster and playing with the pixel information. And this is how the translation can be achieved if I am going to make use of the raster method technique. And if any object was overlapped with this object, then this becomes a slightly complicated process. Now you need to choose, so what was the pixel information other than background, and I need to make sure I'm going to put the right color information in this all this pixel area. So right now we'll just keep it simple, hence we will assume that there is no any object which is going to overlap the object what I want to shift, and for that reason it becomes a simple operation for me. Just put the same color information what the background is going to hold. Right, so with this, now just look at the rotation operation how it can perform. Now the same display area and the same area what I'm going to have. Now for this object I want to apply the rotation operation. So now whatever this information I'm going to have, now this information I'm going to copy to an array. Now just this is an example. This is an example. As I told you, this entire space is made up of n number of pixels. Now each pixel has got its own value. Now assuming this is going to contain 12 pixels, I am going to copy, or I am going to copy this in the form of array. Now this is an array which has got 12 information. Now for this, if I want to rotate this object which is made up of this 12 pixels, if I want to rotate with 90 degree, I am going to rotate this pixel information with 90 degree with counterclockwise direction. Now just look at this. When I counterclockwise rotate this matrix or array, I am going to get in this form. So I am going to have 3, 6, 9, 12 as the first row of pixel information, and the second row is going to be 2, 5, 8, 11 and 1, 4, 7, 10. So for the readability, I am just rewriting this matrix as 3, 6, 9, 12, 2, 5, 8, 11 and 1, 4, 7, 10. Now this was the original position of the object with the 12 information. After applying the 90 degree of rotation, this is going to be the new matrix after applying the rotation of 90 degree. This is fine. And now the same, if I want to have the 180 degree rotation, so counterclockwise I am going to do it 180 degree rotation. Hence I am going to rotate this with 180 degree. Hence the row which was at the bottom will come at the top, and the row which are at the top will come at the bottom, as well as the last column will become the first column and the first column will become the last column. Hence I'm going to do the same operation with all the rows and the columns, just interchange the rows and the columns. That is what the equivalent of this for reader probability. I'm going to put this as 12, 11, 10, 9, 8, 7 and so on. Hence I'm just going to copy this entire pixel information into an array, and I am going to manipulate the value of the array either using the transpose of the array, or I am going to use the flip of an array. Whatever the manipulation I want, I am going to do it, and I am going to make sure the rotation is achieved using a raster method. And this is for 90 degree and 180 degree, or if it is multiple of 90 degree, then this technique is going to work fine. But if you want any random degree other than the multiple of 90 degree, so this is what is some different sort of technique we are going to use. Now this is the area This is the pixel area or the pixel block which I want to subject it for rotation. Hence now I am going to rotate this entire object now. I am going to rotate this entire space area now, and now with the given degree, it can be now 45 degree. And now this becomes the destination pixel area what I want to manipulate, and this is the destination pixel area what should be applied after rotation. Now whichever the area is going to overlap with this destination pixel area, so this is going to apply the rotation pixels. Now this is overlapping, hence this will be copied with the color what this pixel has got. Now this two pixels are overlapping. Now this will be copied with the pixel information what it has got. Hence, so if any other degree other than multiple of 90 degrees, I need to use a different technique by just looking at what pixel is overlapping after rotation, and that overlap pixel should hold the color or should be erased with the background color. So this decision will be taken care, so depending upon what is the amount of overlapping of the destination pixel with the actual original pixel. That is how we are going to apply rotation in raster method if it is other than the multiple of 90 degree angle. Fine. So now if I talk about scaling, now I am just going to have this complete pixel is going to be the pixel block. Now if I want to reduce this by half of the size, that is 0.5, then every pixel whatever I am going to have, I am going to reduce the size by half. I am just going to make sure I am going to have 0.5 of the size. So when I do this, so now again I am going to check out the overlapping, where the overlapping of the new pixel what I have been reduced and the overlapping of the original pixel block. Now I have got two pixel blocks, one block which is with the original size, and the second block which I have been reduced the size by half, and now I am going to put it one over the other. Now whichever is going to be overlapping, the overlapping pixel, that is this entire pixel will have the same information, but the remaining pixel information we are going to erase by setting it to the background pixel color. This is how the scaling is going to work on. Fine. So now by using the raster method, so this is how we are going to apply the translation. Just copy the pixel information, paste it at the destination pixel point, and this original pixel information to be erased by setting this color to the background color. And the rotation, if it is 90 degree, modify the array. If it is not 90 degree, we are going to modify the array in such a way that depending upon the overlapping, and even the scaling, it is going to depend upon the overlapping. And so now with this, we are going to have the mechanism of doing geometric transformation. Now we will see what are the raster methods available in OpenGL program to apply this 2D geometric transformation. So first we will see what are the raster functions available. So now the very first functions are GL read buffer, that is the buffer information what I want to read and store in the default buffer what your OpenGL compiler is going to give you. So similarly, so whatever the default buffer now holds the information, it is going to draw on your display device or on the destination pixel. Hence we are going to have GL read buffer to read the content from the block of memory what you create or the block of pixel what you create, and GL drop buffer will put the information what I've just read on the block of pixel what you have created. And so now this buffer now can take any one of this as the parameter. It can be GL front left or GL front right or GL front. So if you are going to have any stereotopic view, in that case, so there is a difference between GL front left and GL front right. If there is no stereotopic view in your OpenGL program, then this doesn't have any meaning. Hence you can use GL front left or GL front right or GL front, all are same. For simplicity, we are going to use it as GL front, the same parameter with the GL drop buffer. So from which buffer I need to read and to which buffer I am going to drop. So by default, we are going to use a non-stereotypic views, and for this case we are going to use this as GL front. So the first two OpenGL raster function which will allow you to read the buffer information or read the pixel information from the block of buffer and draw the pixel information to the block of buffers. Hence, now with these two functions which I told, I'll be using GL front as a parameter. With these two functions, we are going to have one more raster function which is called a GL read pixel. Now just look at this. It takes two parameter as the left bottom corner of the block what you're going to create right now. Hence, that is what we are going to have x min and y min, the bottom left corner, the block what I want to create in the entire display what you're going to have. And the next parameter is the width, that is the number of column which I want to include in the block, and the height, that is the number of rows which I want to include in the block. And so once this is done, you have defined the area in your display which you need to create this as block of pixel, or the block or area where the transformation operation should be applied. So once block has been created, next you need to tell what type of data format you are going to read or you are going to store. Hence, these are the available data format. Either you read all the three color component as GL RGB if it is RGB color model, or if it is a index color model you can make use of GL index, and if you are reading only the red pixel information, GL red, only green pixel, GL green, only the blue pixel, GL blue, and if you want to read the depth information, the parameter should be GL depth component. And if you are using the stencil effect, and if your OpenGL system supports stencil information in your frame buffer, if you want to read that, the parameter should be GL stencil index. This is what the data format can be. Any one of this can be used as a parameter. And if we talk about GL or a data type, it is going to be GL byte, GL int, or GL float, or this can be GL unsigned byte, unsigned int, and GL unsigned float. It can be of any of this data type. And now you need to pass an array. You need to define an array, whatever the type you are going to pass. If you have used GL byte here, make sure you define or declare an array with the data type GL byte, and that array should be passed as a parameter. And this is the array which will be used to store the pixel information later on, which you can use for any manipulation. That is what happens in rotation. When I want to apply rotation, I need to copy the pixel information in an array and apply any sort of information, either 90 degree forming the transpose of it, or by overlapping pixel information manipulation for any other degree than 90 multiple degrees. Fine. And so now this is going to be the GL read pixel, and with this reader pixel, now just look at this. This is the area what I am forming. So by default I am going to use the GL data format as GL RGB, and by default the data type is going to be GL unsigned byte, and I have been declared or defined an array with the name color array, and that is what the array I am going to pass it as a parameter. Right. So now with this function, I am just going to have one more function called as GL drop pixel. Similar to read pixel, I am going to say GL drop pixel. So now whatever the block of pixel I have been read, now at the same point what or the reference point I have been noted down or I used with read pixel, the same reference point will be used, and now it's going to ask you how many columns should be affected with the new rotation and how many rows should be affected with the new height, or is it same? Just pass the same parameter, and the GLRGB unsigned byte, and this is the color array which I have been modified, which have been altered, so that it is going to make sure it is going to contain the rotation of a given object. Now this is the usage of the read pixel. So read the pixel from the created block of pixel and store it in an array called as color array. Using that color array, I am going to draw the pixel which is going to be the new information or the modified information from the color array. And the one more API is going to be GL copy pixel, so which is going to just copies the information into default pixel area of the default array of OpenGL. Here you are creating an array and you are saying to which buffer or the array the pixel information should be copied. But here I am not telling all those things, or I am not passing any array, hence your OpenGL program will use its default array to store the pixel information or the block of pixel information. But I need to tell what is the area of the block I am going to create and what information I am trying to fetch. Is it the color, is it the depth, or is it a stencil? And this is what the GL copy pixel function is going to do. Along with this, I am just going to have one more function, the raster method called as GL pixel zoom. Now this GL pixel zoom takes two parameters. The one is going to be the scaling factor with the x-axis and scaling factor with the y-axis. That is the number of pixels which I need to modify. If it should be the same amount, the block, if should be the same number of columns and same number of row, so pass the value as 1, 1. If you want to reduce the number of columns by half, I am going to pass this as 0.5, 0.5. And if I want to double the number of columns, I am going to pass appropriate value as 2 for the column or for the row. So depending upon what size of object you require, either you want to reduce the size of the object or you want to increase the size of the object. And if you want to create the reflection of an object, then you can give the negative values. You can give the negative values. And if you want to apply the shearing property, so just keep one value constant and just modify the other value, which is going to be negative value for reflection, and for the shear value it can be anything from 0 to 1 for any one component. This is how we are going to use the raster function right now. So the raster function which is available, using this raster function, now we will see how we are going to have translation, how we are going to have rotation, and how we are going to have scaling. So now whenever I am going to have translation, I just need to copy the pixel information by creating this block of pixel. And for that, the first API I am going to call is GL copy pixel. I am creating this as xmin, ymin. This is the width and this is the height. I have created the area and I am saying I am going to copy the GL color information from the frame buffer. And now this will be stored in the default array. And once this has been stored in the default array, I am just going to say GL read buffer GL friend. I am just going to copy this array into the temporary array where I can use this for the next operation what I am going to perform. Now I am just going to again call the GL copy pixel. I am just going to call the GL copy pixel as xmin and ymin. So with the width and height and GL color, same function, but now this xmin and ymin is going to be the new location. I have given the new location. I am just going to copy this pixels now. Now I am going to say GL draw buffer. So now this function will make sure whatever the information I had copied from the read buffer into temporary array, from that temporary array I am going to copy those information into the new block. Hence by calling this GL copy pixel, and by giving this point as xmin ymin, I have copied this pixel information and stored in a temporary array using GL read buffer. And using this function now, I am using xmin and ymin as this point now. I am copying this pixel information as the block of pixels. Now I am going to execute GL drop buffer. When I execute GL drop buffer, whatever the information I had copied in the temporary buffer will be copied or will be drawn into this new position, new location. Hence the object will be shifted to this new location. And the next job, that is, you need to match this pixel information with the background information. So you need to do it using the raster system, where again I'm going to perform the same 4 operation now. Perform same 4 operation by applying any area of the background and copying to this area. Now this is how the 2D translation is going to happen using the raster method. And now if I'm going to talk about rotation, I'm going to say GL read pixel. So create the area where the rotation should happen and what type we are going to give, and the unsigned byte, and I'm going to say color array. I'm going to copy this entire information into the color array. Now I'm not using default array, because so now to apply the rotation you need to make sure that you are going to modify the value. So to modify the value you need to have your own color array, or you need to have your own array. Now modify the array components or array value, and we are going to call the same function GL drop pixel. So for the same position where I have been copied the block of pixel, the same block of pixel I am going to redraw with the new array which you have been modified, either for the 90-degree rotation or for the 180-degree rotation or for the any given angle. And this is how the rotation will be achieved by using the raster method. And if I going to talk about the scaling, I am just going to create the area where the modification should happen for transformation by using GL copy pixel. Now this is going to create me the area with the GL color information. Now when I use GL pixel zoom, by giving the value, if I give 1 or more than 1, it is going to zoom, or is going to make sure the object will be increase the size. And if I give anything less than this is going to decrease the size, and zoom will be increased or zoom will be decreased. That is how we are going to apply the scaling operation. Now this is how we are going to bring in the OpenGL raster method technique. So an alternate way of applying a geometric transformation on your object. And remember, so this whatever the raster method we are going to use, so this is used for simple transformation function only. And this is what is going to be for this session. Thank you.